Hello everyone, and welcome to this special video I'm recording for my epidemiology students in 2017. I'm recording this because I feel really guilty that I haven't been around the last few days, and because the last class was a video and you have your midterm exam this week. Because your midterm exam is Friday, October 20th, i.e. later this week, I'll be holding a special office hour sessions today. I say today because it is like 1 a.m. right now on Wednesday, and I'll be in my office later this morning from 9:30 a.m. to noon in Thompson 208 to answer all of your gripping last-minute questions. I want you to remember, though, that my policy is not to answer any exam questions, or any questions at all, frankly, in the 24-hour period before an exam. That means Thursday, October 19th, 5:30 p.m. is your deadline for sending me any questions. I will ignore emails and calls after that point. But before I talk to you more about your midterm, I do want to spend a couple of minutes talking about your upcoming poster assignment, which is the big assignment for this class. A few people have started already. Good for you! Good for you, people. I appreciate that kind of diligence and spunk. And because you started early, I think it's important that I set you on the right track. So the purpose of this assignment is for you to be able to frame a research question and to use a certain methodology, in this case it's going to be a literature review, to answer that question the best that you can. Again, after reading week, I'll give more information specifically about what I expect, but I want you to be able to be systematic in how you approach this. So it's not simply a literature review about stuff that you know. I want you to spend some time really drafting out a good research question using the PICO method. Remember PICO, P-I-C-O, and applying your search strategy, much like a systematic review, to the literature to try to answer that question. So you will be judged on the systematic nature of your approach. What are you going to do? You're going to devise a research question. You're going to attempt to answer that question using a search of literature. I mentioned earlier in class that even though you'll be applying systematic review methods, this isn't technically a systematic review. So I tend to call it a structured review, for lack of a better term. You're going to use your knowledge of biases and designs to assess the quality of the studies that you find. So it's advisable to have some sort of predefined a priori system by which you will judge those papers, and also have a good inclusion-exclusion criteria list for determining which studies to accept. And you'll extract information from the studies you find and attempt to answer your research question based on the results from that extraction process. The secret to this assignment is to make it systematic. So, the systematic nature of your research question, is it following a recognized research question format like PICO? What's the strategy you're using to find the information? Which databases have you searched? Which keywords? Which limits to your search? Which Boolean operators? How have you summarized the information? I strongly recommend tables. Strongly recommend them. If you can, throw in some figures as well. The more that you create rather than steal from the papers that you find, the better. And never forget to answer the research question. Okay, that's all I'll say about the poster presentation for now. I hope that you've started and that you have at least got your research question down pat. So as I mentioned, I'll be having office hours soon, as in later today, to answer last-minute exam questions. But the exam itself. So I have 50 questions for you, 50, and even though it's a 3-hour class, you'll only have 90 minutes, 90, to answer these 50 questions. You can bring nothing except any kind of calculator and a cheat sheet, and I'll talk about the cheat sheet in a second, because students are always, oh my god, cheat sheet! It's not as huge as you might think. It's not going to change your life as much as you might think, but we'll talk about that in a second. The exam that I prepared for you has mostly theory questions, and by theory I mean text, I mean non-computational, and 21 questions in which you need to do some math. So the computational questions mostly involve computing incidence, prevalence, and mortality rates. And as you know, that's mostly dividing two numbers. Really simple grade 3 math. The hard part is figuring out which two numbers to divide. In general, I do not ask trick questions. In general. Maybe I slip up now and then. But I'm not trying to confuse you or trick you based upon a nuanced and subtle understanding of things. I'm testing actual knowledge. Maybe you'll disagree when you see the questions, but I don't think they're trick questions. Agreement, we touched upon via video using the kappa system. Or did we? Did we? I don't remember. We didn't do agreement. We didn't do agreement. Forget agreement. Yes, we did. We did agreement. Yeah, we did the kappa method in a video. That's right. Survival, both simple survival and Kaplan-Meier. We did that. And standardization using the indirect method and the direct method. The agreement part I feel guilty about because that was a video class and I didn't get to teach you directly as well. Kaplan-Meier. But I think you'll be fine. Okay. So the cheat sheet. Your cheat sheet is an 8.5 by 11 inch page, double-sided, and you can bring whatever you want on that sheet. You can bring in congratulatory letters from your mother, cute pictures, doodles. If you're really keen and you write really, really small, you can probably just recreate the entire textbook if you want. The reason I let you bring in a cheat sheet is that this is not a class about memorization. You shouldn't be spending brain power memorizing formulas. Write them down instead. I'm not going to give them to you, so you write them down. As well, what I find is if you take the time to create really complex and interesting cheat sheets, that's your study process. So it's a way to encourage you to study. Write on both sides. I don't care what's on them. I really don't. So here are some sample questions. I'll give you a judging scenario and ask you to compute a kappa score. Kappa was on one of the videos I sent you, and to interpret the result. Or I'll give you a scenario and ask you to identify the type of bias. Or for Kaplan-Meier, I'll give you the data as per the easy method. Remember the easy method versus the hard method? And I'll ask you to compute the product limit. So I do not ask trick questions. There may be one there, and that may, maybe kind of tricky. We'll see, right? And I've really made an effort to phrase the questions as simply as I can to accommodate people for whom English is not the first language. But precision is important. So when I phrase things grammatically, I've done so in such a way to make them as unbiased as possible. Perhaps I failed, but I've been refining these questions over the years. So you're going to have to read pretty carefully to get all the information you need to extract the right numbers to divide. And I've got a lot of questions that say, which of the following is true? Why? Because it's hard thinking up questions, man. It's hard. So sometimes I gotta do this type. So here's some more sample questions. Here is a study of 150 hospitalized patients begins with 10 confirmed cases of sore butt disease. The study is followed for 5 years, during which 16 new cases arise. So right away you see it's going to be dividing some shit. You gotta decide which numbers to divide. First one, the prevalence of sore butt disease at baseline. What's baseline? Baseline is before those 5 years begins. So the denominator is going to be 150, and we begin with 10. So 10 over 150, right? That gives us whatever, 6.7%. Okay, next one, the prevalence of sore butt disease at the end of the 5 years. Okay, so we got 10 cases plus 16, 26 over 150, and we get 17.3. The incidence density of sore butt disease over the 5-year interval. Okay, so this is a bit, incidence density we use mostly for following up individuals who have been in the study for different lengths of time. These individuals have been in there for all for the same time, so this is really an exercise in just converting to the appropriate denominator. It's actually easier than most incidence density questions. So we have 16 new cases, those are the incident cases, divided by how many are at risk, where it's not 150, it's 140 because 10 already have it. 16 over 140, but over a 5-year period. So 16 over 40 divided by those 5 years gives us 2.3 over 100 years. If we divide that by 100, if we multiply that by 100. Okay, what is the cumulative incidence rate of sore butt over the 5 years? So the same question, except express it as cumulative incidence instead of incidence density. Well, that's going to be R16 over 140, but we're not going to divide through by 5 because this is the rate over the entire 5-year period. Okay, where did all those go away from? There it is. There it is. For some reason that keeps disappearing. Weird. Alright. So, here we have a study of 708 extremely elderly cancer patients, and 84 are alive at the end of 5 years. So, we're given here the expected survival rate of 86%, and the question is asking what is the relative survival rate. So, relative survival rate is the survival rate in our sample divided by the expected survival rate, which is the survival rate in the general population. Okay, so that's going to be, the denominator is 86, so the numerator is going to be 84 over 708, right? So 84 over 708 times 100 gives us 11.9%. That's the survival rate in my population. The relative survival rate is going to be that number divided by 86. That gives me 13.8. Number 5, same group. At the 1 year mark, there are 495 left. At that point, 75% would be expected to live. Okay, because that's the relative survival rate. The general population survival rate, rather. So computing the relative survival rate, that's just a matter of getting this ratio and dividing it by 75. Okay, so that ratio is 69.9%. Divided by 75, we get, well, it's 93.3, but you get the idea. So what does this tell me? Here, at 5 years, the relative survival rate is 14% or so. Here at 1 year, it's 93%. This tells me, why does that keep disappearing? That's weird. This tells me that this particular disease gets pretty fatal after 1 year. So the survival at 5 years is profoundly worse than 1 year. I don't know why that disappeared. Weird. Okay, let's do this again. 78 patients in a 5-year study. In year 1, 2, oh, this is a good one. So this is looking at survival rates for the whole sample versus the cause-specific survival rate. First question, what is the 5-year survival rate of sore butt disease? Okay, the way we do this is we look at all the ones who died at 5 years. Okay, died of what? We don't care. All we care is that they died. We do care if they disappeared on us. We can't count those as having died because this is just basic survival. So how many died total? 1, 2 in year 1. In year 2, another one dies. In year 3, these guys move away, but they don't die. In year 4, 2 die, right? Of sore butt disease, and 1 dies of heart failure. So 6 dead total. So at 5 years, 6 died. So that means 72 out of 78 remain. That gives me 92.3%. The second question, though, is asking for the cause-specific survival rate. What is that? That means we only care about the ones that died specifically of sore butt syndrome. So how many of those were there? There were 2 in year 1. There was 2 in year 4. Right? Total of 4 died. So that's 74 out of 78. And that gives me, well, that should give me 94.9%. I don't know why it keeps disappearing. That's annoying that thing keeps disappearing on me. Clearly I'm technologically incompetent today. The number of people who die, by the way, this is an example of a theory question. I've defined theory as, this kind of stuff. Number of people who die of a disease divided by the number of people who actually have the disease is called, well, that's going to be, my friends, the case fatality rate. Right? Cool. It disappeared again. Weird. Annoying. And last sample question. A study in which the numeric results of multiple studies are mathematically aggregated together to obtain an unbiased estimate, blah, 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 blah. That is meta-analysis. Now, some people may confuse a meta-analysis with a systematic review. Remember, they are different things. A meta-analysis is the statistical combination of the results of a variety of papers. A systematic review is a review of those papers. Sometimes systematic reviews have meta-analyses, but they don't have to. Okay, that's all I got for you. Do not worry, my friends. Most people do very, very well on the midterm. It's the exam final where I give it to you hard. But just do the practice questions and you'll be fine. Remember, the majority of questions are theory questions, so understand all this other theory stuff. And that's going to be the heft of what you actually end up being challenged with. That is all. See you later.